Okay, for first chapter, we will learn about number system. Okay, so in this chapter, we will learn about real numbers, complex numbers, type of real numbers, indices, logarithm, and surd. Okay, let's have a look at the different type of real numbers. Okay, so in real numbers, we have a classification of real numbers, meaning that we have different type of real numbers. So why are different type of real numbers are important? The different type of real numbers are important because we want to instruct to the program, so any program in the computer, so that the computer will understand the instruction given so that it can be processed correctly. Okay, now, what is different type of real numbers? Okay, first is rational numbers. Okay, now what is rational numbers? Rational numbers, number that can be expressed as a ratio between two integers. So any number, as long as we can write in the form of the form of fraction of two numbers, we call or a ratio, we call it rational number. Okay, for example, A over B, A can be any numbers, B can be any numbers, or 0.3 bar. Okay, 0.3 bar here means that 0.333 and so on. Okay, number 3 is repeated again and again. Okay, this is rational numbers. And the decimal, it can be a repeating number or non-repeating number. Okay, that one is considered as a rational number. Okay, the 0.152 bar here, if we write it in the standard way, it is 0.152, 152, 152, and so on. Okay, this type of numbers are considered as rational numbers. Okay, next is what is irrational numbers. Irrational numbers is a number that cannot be expressed as a ratio between two integers. The rational number which are in decimal form do not have a repeating decimal. 1, 5, 2, 6, 3, 5, 8, 9, dot, dot, dot. Here means that there is other number followed by 9. And we cannot predict the pattern of the numbers. What will be the numbers next? That is considered as irrational numbers. But for rational number, we can predict what is the following numbers if it is repeating. Okay, that's the difference between rational and irrational numbers. Okay, next is natural numbers. Okay, natural numbers are numbers that are used for counting. So they are also called positive integers. We use this number to count, to start counting 1, 2, 3, 4, 5, and so on. So this is called natural numbers. Okay, next is whole numbers. Whole numbers is also a natural number, but we add 0. We add 0, it is a natural number, but we add one more element, which is 0. So we call that natural whole numbers. Okay, for integers, integers are the most common used numbers. Integers can be negative number, it is round numbers, negative, round numbers, 0, and also positive round numbers. It includes natural numbers and also whole numbers. Okay, converting decimal into fractions. Any decimal numbers can be converted into fractions. So how do we convert decimal into fraction? Okay, example, let's say we have x equal to 0.555. Now convert this into a fraction form. Okay, 555, we'll put bar on top of a single 5 here. So let x equal to 0.5 bar. Okay, now it becomes equation 1. Equation 1, both sides left and right multiply by x. Multiply by x is become multiply by 10. Sorry, both sides multiply by 10. So left is 10x, right is multiply by 10. So we move the decimal one place on the right. So it becomes 5.5 bar. Okay, now equation 2 minus equation 1. Okay, make equation 2 minus equation 1. So we have 10 minus x is 9x, 5.5 bar minus 0.5 bar is 5. Then you solve the equation, it becomes 5 over 9. So x equal to 0.5 is equal to, in a fraction form, is 5 over 9. Right? Okay, so you can do this example using the same example provided earlier, right? Okay, next is properties of real numbers. Okay, why do we learn properties of real numbers? Okay, if we were to give command to the program to be executed by a computer, we need to define the properties of the numbers first, so that the program or the computer will understand the properties provided by the programmer. So once it is understandable, the command is understandable, the program can be executed by the computer correctly. So that's why properties of the real numbers are important. Okay, let's have a look what are the properties of real numbers. So let's say we have A, B, and C as any given real numbers. First is commutative property. So what is commutative property? Commutative property is when we add the two numbers, A and B. A plus B is equal to B plus A. So in this case, the sequence of the number is not important in the addition operation. So we can put A first or we can put B first. Same also goes for multiplication. A times B is equal B times A. Okay, next is associative property. So let's say we have A, B, and C. We can add up any two numbers first and add by the third number. Okay. Also here, the sequence are not important. We can add up the first two number first, followed by the third number, or we can add up the last two numbers first and then add the first number. Okay. Same also goes for multiplication. We can multiply the last two number first and multiply by the first, or we can, it's the same as we multiply the first two number first and multiply by the third number. Okay, next is identity. Identity property is if 0 is added to any number, the result is the number itself. So this is called identity. So it does not change the look of the number by adding number 0. 0 means that we didn't perform any operation. Okay, so it preserves its own originality. Okay, so this is called identity property. Okay, for multiplication, the identity property is multiply by 1. So A times 1 equal to A. So number 1 become the identity property for multiplication. So once it is multiplied, it preserves its own originality. Okay. Okay, next is inverse property. Inverse property for addition means that we need to find what is the inverse of the number itself so that it goes back to its originality. Okay. Okay. For addition, the inverse of the number is negative. So A plus the negative of its number, it becomes 0. Okay. For multiplication, the inverse of the number is irreciprocal. So this is called its reciprocal. when any number multiplied by its reciprocal, it becomes 1. Okay. Okay, next is distributive property. Okay, for distributive property, when we have a sum of two numbers, we multiply any sum of two numbers. So we distribute by open up the bracket, distribute the multiplication equally. Okay, for example, A multiplied by bracket B plus C. So by using distributive property, the equation is the same as A times B plus A times C. Okay, next is set and intervals of real numbers. Okay, set, let's say S is a symbol of set and A is the element inside the set S. So the symbol E here is element of. A is any number that is inside the set S. Okay, if A is not inside S, we use this element, meaning that A is not element of S. Okay, in set also, we can represent in the form of inequality. Okay, for any number A and B, if B is greater than A, so we can use inequality form. Okay, we read as A less than B. Right? Okay. Next is how do we represent the numbers in the form of set in notation, inequality notation, and also on the number line. Okay, in the set notation, so this is the symbol of set. We have A and B here. Close interval from left and also right. A close interval given by a square bracket like this. It means that the number A and B is included in the set. It is also defined in the set. The inequality form, it is right in this way. As long as B is greater, if B is on the right side of A, meaning that B is greater than A. So we write in this form, A less or equal. Equal is included here because the interval is a closed one. Okay, a bracket one. So we have X. The right number, letter X here, we must write in here, must include in here, meaning that we want to define X in which family. Okay, if X is a real number, we put X element of R slash where X is in between A and B. Okay. Okay, in the number line form, we put in this form where we draw a full dot here on the number where the number exists. Okay, because A and B included in this set, so we have a black dot here. Okay, it's a black dot here, full dot, meaning that A and B is included in the set. Okay, for open interval, this is open interval. Open interval meaning that A and B is not included. Okay, if you write in the inequalities form, it is less, X is between A and B, where equal sign is not included. Okay. Here also, we represent on the number line by drawing a blank dot, not a black dot like this. This is a full dot, this is a blank dot. Kita tak hitamkan di tengah-tengah tu. So, on point A and B, since it is open interval and it is not included in the equation, so kita draw a blank dot. Okay, half open interval. Half open interval is either start with the open interval and with the closed interval or otherwise. Sama juga. Both here are called half open interval. Maknanya only one side is open, another side is closed. It's a combination of closed and open. Okay. In the inequality form, we write in this form. Okay, equal sign appear on the side where the number is included. So in this set form, the starting interval is included, A is included, so we put in this form. Okay, same also for representation on the number line, kita hitamkan pada A. Sebab A is included in the set and also in the equation. Okay. For infinite interval, okay, for infinite interval, infinite meaning that in the set, infinite number are included. Infinite is an exist number. So it's a very large number, but we do not know what the number is. We need to define it. Okay, for example, okay, negative infinity, and B. Negative infinity. Okay, for negative infinity and infinity, the bracket we must always use open. Okay, open interval. But we cannot define exactly what the number is for the infinite. Okay, infinite. Okay, so here for minus infinity B, answer it for interval is x less than B. Okay, on the number line, we put arrow here. Arrow on the left means that we have more numbers on the left of B. So for infinity, for negative infinity here, we represent it by arrow. So it means that we have more numbers on the left of B. Okay, on the B side, it is a blank dot because inside set here, B is not included. X less than B. Okay, for positive infinity B, I think this is supposed to be negative infinity. If on the left side, it's always negative infinity. For negative infinity B, we have x less or equal B. And on the number line, we make a full dot here. It means that B is included in the interval and also in the set. Okay, for positive infinity. Positive infinity must always be on the right side of any numbers. Okay, also it is open interval. Okay, for this symbol, inequality form is x greater than A. Okay, on the number line form, it is blank dot, and the arrow on the right side is given on showing that it is positive infinity. Means that we have number on the right side of A. More numbers on the right side. Okay, for A in infinity and A is included. So for inequality is x greater or equal A. Okay, on the number line, the black dot here, okay, the full dot here represent that A is included. Okay. Or interval form of negative infinity to infinity also can be represented as R. R here means that real numbers. All numbers are included. This is another way of writing interval form of negative infinity to infinity. Okay, so this is our example. So you can try to make this example and then we can share answers to discuss. Okay, that's all. That's all the presentation for today, the lecture for today. So I hope we can continue the hands-on exercise. Okay.